Symposium celebrates innovative research and highlights the outstanding work carried by academics, researchers, and of course students. We are excited to have you all here today as we dive into the second day of knowledge sharing and recognition of excellence. So I'll briefly go over the agenda for today before starting. So we'll have the welcome by the session chair initially, followed by the best paper presentations, and we'll have a short working break in between, followed by the next set of presentations for the best paper. And then we'll have the awards for the participation, as well as the best paper and best poster awards as well. Then we'll conclude with the vote of thanks. So to formally commence today's proceedings, I invite Dr. J.R. Gamage, the chair of the symposium, to deliver the welcome address.
Right, thank you very much, Prabhathiya. Again, apologize for the delayed start, but anyway, as the symposium chair, let me formally welcome you and Professor Gayatri, Chair Research Week, and our fellow academic staff members, Director ERU Dr. Sulochana, and our panel member Dr. Peshala, Dr. Lihil, and Dr. Kasun, and all the presenters, authors from different universities in the different parts of the country. So I would like to show some statistics today before welcoming. This time we got over 50 submissions, out of which we accepted through a thorough revision or review process 31. Right? Then I'm glad to see there's a multi geographical submissions this time. More than Moratua, there are other people. So I would like to mention there are international affiliations as well. 4 international university affiliations, one in University of South Wales, a German university of which the name cannot be pronounced, and University Shanghai Maritime University and IIT Madras. Also they are in the author panel affiliations. In locally we have University of Rajarata turning up in high number of submissions, and University of Jaffna, Kalaniya, Peradeniya, Open University of Sri Lanka, and Moratuwa. 6 universities locally participating. So this is kind of now with the international affiliation, this becomes now international symposium, which I am happy as the chair, because last time we had I think only 1 or 2 international affiliations. This time it has been improved. Now, as a sustainable matter, we have discussed with the Dean Faculty of Graduate Studies as well, that we should encourage all of our PG, postgraduate, taught and research program students to submit their papers and disseminate their knowledge and get the experience of presenting. I remember I also presented my final year project in the ERU Symposium in sometimes back, about 20 years back, which was held in a hotel. That time there were no MOCON. So we were forced by our supervisor, you submit, otherwise it's not going to happen. The evaluation is not complete. So it's 2-page abstract, still there in my research gate, my final year project. Those days we never had ISSN. The benefit is this time you have ISSN, which is published online through University of Moratuwa library. So you can show your final year or postgraduate project to whoever who's you are going for an interview or whatever. You are visible on the web, of which your research details. So you are a credible person then. Right, with that I would like to formally welcome all the panelists and our staff members, fellow staff members, especially people who are traveling long way and 2 days. I know it's a hard defect. We will consider that next time, if we can compress this to a 1 day, because Rajarata and Jaffna people is finding it difficult to travel. So there was request, but I encourage them to come physically, because the symposium is we meet each other and networking is the prime importance. And thank you very much for coming, and welcome you all. Over to you, Prabhati, to continue the proceedings.
Thank you, Dr. Gamage, for that insightful introduction and warm welcome. It is now my pleasure to introduce the session chair for today, Dr. Kasun De Silva, Senior Lecturer at the Department of Civil Engineering at the University of Moratuwa, and our distinguished panel members, Dr. Lihir Subasinghe, Senior Lecturer at the Department of Mechanical Engineering at the University of Moratuwa, and Dr. Peshala Jayasekara, Senior Lecturer at the Department of Electronic and Telecommunication Engineering at the University of Moratuwa. Now we move to the first segment of today's presentations. Out of the many submissions we received for this year's symposium, 8 papers were shortlisted to present today. And these will be competing for the Best Paper Award. Each paper will have 10 minutes to showcase their work, followed by 5 minutes of Q&A, and a bell will be sounded 30 seconds after your allotted 10 minutes, and you are supposed to stop, go through your slides and stop the presentation after the bell is rung. So to guide us through this session, I now hand over control to the session chair.
Go with strictly with the time schedule, and the allocated time still will be displayed in this computer as well, where you can refer while you are doing the presentation. So let us start. So the first presentation, blade pitch angle and camber optimization of a vertical axis wind turbine using numerical simulation, authored by NMIW Bandara, WMKS Veerasekara, and SDGSP Gunawardana.
So, good morning, everyone. So, I am NMIW Bandara. I am one of the authors of this blade pitch angle and camber optimization of a vertical axis wind turbine using numerical simulation extended abstract. So, this is co-authored by Mr. WMKS Veerasekara and Professor SDGSP Gunawardana. So the contents of this presentation you can see in this slide. So as an introduction, there is a comparison in between horizontal and vertical axis wind turbines. So the major drawback of vertical axis wind turbines are they are less efficient than this horizontal axis wind turbines. Bed's limit is the theoretical maximum power conversion that we can get by wind turbine. So the primary goal of this study is to optimize blade pitch angle and camber for enhanced vertical axis performance using ANSYS Fluent package. So objectives also you can be seen. These are the milestones we have completed. First, 2D simulation model was developed and performed a benchmark test. Run multiple simulations for different pitch angles and extend this to several camber versions. So you can get an idea of a beta with these two annotations. So this is the methodology. First literature review was developed. Then this is the 2D simulation domain, and these are the 3 blades that we used. So this is the mesh details. Mesh independence test was initially performed. This is after meshing. So this is the near wall meshing in each meshes, mesh 0, 1, 2, 3. So these are the results of mesh independence tests. I have benchmarked this against this Alaimo et al. Paper. It is a major reference for this study. So this is what we got in this our study, and this is the Alaimo's studies results. So mesh 0 was selected. This is the mesh convergence test results. So mesh 0 was selected. So I will discuss later why exactly the 0 was selected. So these are the we have get the results basically on the the basis of torque coefficient. This is the equation for getting the instantaneous torque coefficient, and this is called the tip speed ratio. You can see the notations, and these are the results got for the instantaneous torque coefficients at various tip speed ratios. So here 1.78 was selected because it gave the maximum average torque for further studies. So this plot shows the model validation best fitted model. Blue color one is our study, and against the alignment analysis study, it is as an average 88% accurate. So this is for the optimization purpose. We have used -10 to +7.1 pitch angles for 3 different airfoil shapes. These are their notation. TSR 1.78 is equivalent to a rotational speed of 120 RPMs. So this is the final results we got for this study. So as for this plot, this table shows NACA 0.021 blade at -5 of a pitch angle gives 7.6% of improvement, which means if we have 100 kilowatt vertical axis wind turbine, it will be given 107.6 kilowatts if we use -5 of pitch angle. So these are the contour plots obtained using the ANSYS software at these specific azimuthal angles. So here, just think about this top blade. Here, it's considered as 0, and exact blade here at 90-degree counterclockwise rotation. Likewise for complete revolution. This is the pressure contour plot, and this is the velocity contour plot obtained. So for the discussion, mesh 0 was basically selected. It gives the dimensionless y plus parameter less than 5. It should be, when doing CFD simulations, either less than 5 or more than 30. So this is the values that got for each blade. There were 3 blades. For against their x direction position, the y plus values were plotted using ANSYS. So the y plus value is a dimensionless quantity used to evaluate the resolution of a boundary layer mesh near walls in a fluid flow simulation. So this is what I told earlier also. At -5 pitch angle, 7.6% improvement at symmetrical NACA 21 blade. These 2 blades has a camber. So rather than having a camber, symmetrical airfoil gave the maximum improvement. So the as a conclusion, cambered airfoils yielded low power coefficient values compared to the symmetrical airfoil. And the future research directions, you can see this is only done for 2D domain. We can extend it to 3D simulations as well. So also refined pitch angle investigations can be done. Can explore more airfoil shapes and cambered ones as well. And dynamic pitching mechanisms also can be considered. Field validation can be done also. This is only made on the basis of numerical simulations. Also, this is done for 3-bladed one. 4 and 5, likewise, even 2-bladed configurations can be considered as well. So these are the major references for this presentation I have used. This is the one I have used for the benchmarking. And thank you very much. That's it for the presentation.
For your presentation. So now it's time for questions and answers, which have been allocated 5 minutes. So any questions or clarifications from the audience?
Okay, I have a few questions. Thank you for the presentation. Now, in your presentation, you mentioned about optimal beta, right? That is the pitch angle.
Yes, sir.
Now, the word optimal is a very dangerous word unless you have mathematical proof that that is the best possible beta that you can achieve. It's not 4.95, it's not 5.1, but exactly 5. So, have you mathematically done like a formulation of some equation to show that that is the best possible, or do you have a certain resolution? Okay, you have 5, then 2.5, then 2, something like that. Change.
Yes, there is a 2.5 resolution because this is not an analytical one. So this is a numerical simulation. So I only could do the simulations for certain after setting certain pitch angles. So in between that, so that's also a future direction if you need to achieve. So in between, so I have said -5 and also -7.5, -2.5 were simulated, and in between that there was no simulation. So that's I also mentioned in the future directions. You can do the refined pitch angle investigation if you want. This might be not the best highest point of this curve. The curve was like a maximizing curve here at -5. Sometimes it can be between -2.5 to -5. So
right. Okay. One more question regarding the related works. So where does your output compares with the other work? You mentioned a major reference, right? In which year was that published?
It is published in 2015, I think.
2015. Okay, so you compared your work with only that particular work?
For benchmarking, only that I have used this Alimo reference. So 2015, it's published. for the when I was doing the literature survey, I have used some recent references as well, around 2020. So here only mentioned these references I have used to in this presentation only.
Okay, thank you very much, and
Thank
all
you.
the best.
Thank you.
Thank you for the presentation, and I like to know what is your justification regarding the selection of mesh number 0, and you have used 4 different meshes.
Yeah.
And
Yeah.
what is the reason for going for mesh number 0, and what is your justification behind it?
I have, if you may have seen the mesh convergence test. There was a plot. So this here actual CT max and CT max and CT minimum is extracted from this plot. So in the mesh convergence test, mesh going from 3 to 1, mesh is more refined. So here you might see there's a deviation from the CT minimum when it comes to mesh 0. Mesh 0 was exactly used because that Y plus criteria I have mentioned in the discussion. Only mesh 0 was have gave this Y plus values at less than 5. Other ones it gave results between 5 and 30. It's when doing that, ANSYS doesn't exactly know how to solve that one, either using direct numerical simulations or using substituting to the wall functions. So it should be either less than 5 or greater than 30 to 300 between. That's the major reason.
Okay, thank you.
Okay, thank you, Bandaru, for your
Thank you very much. Thank you very much.
So let us move to the next presentation. Autonomous wheelchair robot navigation incorporating user expressions. Tisara Patirana, AGBP Jayasekara and BGDA Madhushankar.
Good morning, dear sir, madam, and my dear research fellows. My paper regarding the autonomous wheelchair robot navigation incorporating user expressions. Presenting author I am Tisara Patirana. So here my content: introduction, graphical abstract, problem statement, literature review, research gap, aim and objective, methodology and related works, results, conclusion and future works. So here my brief of the introduction. I designed this kind of robot to reduce the wheelchair user stress. So the main objective of this wheelchair is, for example, design and development of autonomous wheelchair navigation simulation to emphasize how to reduce user stress by doing some activities. For example, when wheelchair suggests to user to go somewhere in the house according to the user selection, when select whatever location, robot check current emotion of the user by facial expression algorithm. That's the main point of this wheelchair. So here my graphical abstract. I integrate RGB camera to read user frontal face, and convolution neural network has been developed to predict user facial expression. According to that facial expression, here some major suggest moving location to make user some overlapping. I'm really sorry. There's some overlapping. Suggest moving location to make feeling happy. This is the first model of this research. After that, this node published this topic to suggest different moving paths and activities. After that, this, for example, if user feeling sad, the system has the capability to suggest go somewhere, let's go somewhere to reduce your sad feeling. After that, the system has a capability to suggest a different path to move existing location to desired location. Here the autonomous wheelchair robot integrating with RGB camera and LiDAR sensor. Here now the graphical abstract of this research project. Now my problem statement. Actually, it's unable to reduce the stress by using adapted general daily routing for the actually now my problem statement is it's unable to reduce the user stress by doing some daily routing activity for the wheelchair users. So this is key highlighted point of this problem statement. Now here my literature review. I split the entire literature review into 3 categories: broad scope, technical areas and exact similar research. Here my broad scope: develop CNN, navigation algorithm development, mobile robot simulation. I do literature to enhance the broad scope of this research by doing the other developed activities. Now after that, I split the entire broad scope into 5 technical areas. By investigating the literature doing this kind of technical areas, I finally search for the exact similar research. Now find I research gap. Here the key highlighted part in the literature review. Actually here the most highlighted part: average general human relaxation time from sad to happy may be 5 minutes. Finally, when I describe the research gap of this research, there are a lot of available user stress reducing methods incorporated in the wheelchair. Actually, the available system don't have human-like thinking pattern. It can be defined as a proactive service. So I emphasize that kind of proactive service to describe my entire research project. Here my aims and objectives: 3 objectives: to develop convolution neural network, to develop an algorithm to suggest household location, simulate the present concept by using SLAM, AM, CL and dynamic window approach. My methodology: first I develop CNN model development, proactive location suggestions, proactive navigation path suggestions, simultaneous localization and mapping, also robot simulation. Here the main algorithm run inside the simulation. Actually this is the wheelchair inspired differential drive robot developed in the gazebo simulation in robotic operating system. Here my household scenario to simulate the entire process. Now you can see the entire map of this simulated house, kitchen, play area, bedroom, TV room, outdoor room. If robot existing this point, robot can suggest to move any location by according to the user facial expression to reduce the user stress. Here some results. There are shortest paths available here. There are, for example, if your wheelchair want to move from A to B, doing shortest path if user has a happy feeling. If user has sad feeling, the system may suggest go from A to B through this outdoor view area. This outdoor view area has the capability to see the outdoor view while navigating from A to B, for example, lobby to kitchen. So this kind of proactive suggestions has been enabled to describe this research. Here my results, average mean of error, average error, navigation error of this 0.06. Now the other one is simulated error in the navigation. You can see some here is struggling to move one location to another location by doing some this multiple path. Actually, this is error. This should be reduced in next step. So my conclusion. Actually, this simulation regarding the user feeling to reduce user sad feeling or natural feeling to from the natural feeling to happy feeling. So my design and development wheelchair. The next step. This wheelchair develop as a real-time wheelchair simulation. Also design and develop AI-based proactive suggestion generator to enhance proactive service to the user after doing proper human analysis. Here's my next step. Now, here the references available on this research. Thank you very much for your attention.
Okay, thank you very much for your presentation, Tisara. So now it's a time for questions and answers.
Okay, thank you for the presentation. I have a few questions. First one is, you mentioned about detecting facial expressions using CNNs,
Yes,
right?
sir.
Have you done anything novel on that, or is it, are you using an existing network with pre-trained weights?
No, sir. I developed convolution neural network from scratch. Actually, it's a convolution neural network 3 architecture.
Yeah. Can you explain the internals of that? How many layers are there?
There are 3 hidden layers. I observe colored images from user frontal face. Then I add some filters to enhance the good feature of the face. According to that filters, I develop 3 hidden layer convolution layers, and also I flat the entire convolution layer to get some flattened idea.
I believe there are more like similar works on facial expression detection using CNNs.
Yes, sir.
So what is new in your work?
So actually, convolution neural network has a, there is no any new thing in the convolution neural network. But I developed a proactive part of this research to describe the entire research like a human-like thinking. The wheelchair system has a capability to measure the user facial expression, and it has a capability to get a decisions to make user happy feeling.
Okay. Have you compared your network with existing networks for facial expression detection, and where does your work stand?
Actually, sir, I got some 85% accuracy of this system. But when I compare some facial expression systems, it has some frame rate issues. For example, when I describe I can't remember what's the system. When we use this kind of thing, it has a frame loading delay because it give much more processing time to get the output. That's the main reason why I developed the entire convolution neural network from scratch.
Okay, my other question is, you mentioned about autonomous navigation, right? The
yes, sir.
SLAM, dynamic window, and AMCL. These
Yes.
are somewhat old techniques, like I think 20 years or so old.
Yes.
But in your future work, you mentioned about incorporating AI into these kind of things. I think that's where some novelty would have been incorporated, merging some machine learning techniques to the existing ones.
Yes, sir.
The ones that you have already used are somewhat old in my opinion. Anyway, thank you very much.
Thank you very much, sir.
Thank you for the presentation. And I believe in your case, you whatever the activity that the robot does, it is the major requirement is to change the mood of the person, sad to happy. Am I correct?
Yes, sir.
Okay. Then in your research work, how do you validate that by doing this particular movement, how do you know that the person has become happy?
So actually, there is no any in the existing research. There is no any feedback to make user to check user happy after the navigation. But I follow some literature reviews to get an idea like this. Average general human relaxation time from sad to happy may be 5 minutes. So I coded the entire robot navigation part to stay somewhere, like for example, in the play area to play the video game or something like that. I coded the entire system to keep the entire wheelchair moving in the play area within 5 minutes. Then,
so in that case, actually, you cannot justify whether the person becomes happy or not. So it is like automated wheelchair that to a certain place and stay there for 5 minutes, and basically there's no human interaction with the robot and the person who is sitting there.
yes.
So without validation of the happiness part, it seems like a bit off from the topic that you have selected. That is my opinion.
Yes.
Okay. Thank you.
Thank you very much.
Okay, since the time has run out, we shall move to the next presentation. Thank you again.
Thank you, sir.
So the next presentation, comparative analysis of autofocus measures for blood film microscopy, authored by Heva Vitarana DC, Jayatilaka WADM, Dasanayaka VPC and Amarasinghe YWR.
Right. Good morning, everyone. I'm Dinit Heva Vitarana. Today I'm here to present my research, comparative analysis of autofocus measures for blood film microscopy. Let's say you have a fever or a sore throat, so you go see a doctor. So if to give you a correct diagnosis, he probably will order some blood work. In the modern medicine or in telemedicine or telepathology, how we take care of blood film diagnosis is to use a digital microscope and take a series of images and then stitch them together to create a whole slide image. And when we are creating the whole slide image, the blood film has actually a thick end and a flat end. So the from the blood slide to the objective, the distance should be, the position should be different in real time. You should change the position in real time. So as you can see, the microscopy has become an essential tool in clinical diagnostics, particularly in blood film analysis. But accurate imaging is crucial, as defocusing can obscure vital cellular details. So what is the solution for that? Autofocusing. Despite the importance of autofocusing, there is no consensus on the most reliable focus measure for blood film analysis, particularly. And this study addresses this gap by systematically evaluating 28 focus measures across 3 major categories: derivative-based, statistical-based, and histogram-based. Our aim is to identify the best performing metrics for accurate and reliable autofocusing in my blood film analysis. Right, let's dive deep into the problem. In the blood film analysis, maintaining the precise focus is crucial for detecting fine cellular details. Since any defocusing alone, C-axis can mask features affecting diagnostic accuracy. So the current methods we use, we have variety of focus measures, but they often struggle with noise, poor accuracy, or inconsistent performance in medical imaging tasks. So this research aims to systematically compare these focus measures and recommend the most reliable one. The primary objectives of our study is to develop an algorithm to accurately identify the optimal focus point for blood film microscopy and evaluate performance using 5 criteria: accuracy, range, false maxima, width at 50% maximum, and overall score, and recommend the most reliable metrics for blood film microscopy. And for this research, I have used 3 data sets. First one is I have generated synthetic sinusoidal images, since they actually relate to a cell structure. So I have created the sinusoidal images in different frequencies, and I have applied Gaussian blur to create the C-focus stack. I have the distance for C-focus stack simulates 0.5 micrometer resolution. I got that figure from the diffraction table of 100x magnification. And also I got from the internet resource, I got 301 focused blood film images. Then I put them through Gaussian blur to get the defocusing stack. Moving on, I have another set, empirical data set from with defocusing stack, 15 images stack, more than 50 image stacks are there. So with incremental defocus of 0.5. Moving on, after generating this data, to ensure the consistency, I have pre-processed these images by resizing them, grayscaling them, and to make them computationally efficient, I have normalized them. Once I get these images in one consistency, I create these focus curves from each image stack with all 28 focus measures. So this is the focus measure curve fit graph for defocus image stack. I have 2 other separate images like this graph, 2 other graphs for sinusoidal images and also focus images. So once I get these graphs, I put them through a performance criteria. Accuracy measures how close the maximum focus measure is to the correct focus. And the range, the distance between 2 local minima around the global maximum. So wider it is, better for our algorithm. And the number of false maxima counts the local maxima excluding the global maximum. And the width at the 50%, width of the curve at half of the maximum value. So I check the width at the half of the maximum, the narrower the better. And at the overall score, I check the combined score with Euclidean distance formula. And at the other table, you can see the 28 focus measures with derivative-based, statistical-based, and histogram-based categories. Once I get these, put them through the performance criteria, I get 3 tables, one for each data set. Then with weighted addition, I get this final ranking table. So as you can see, the best performer is variance of gradient. this is a graph, a table where I show all the best performers of our research. So we can see variance of gradient, squared gradient, energy gradient, Brenner gradient, GLCM contrast, sum modified Laplacian, Tinograd, and Laplacian sum. Other than the GLCM contrast, all of them are in the section of derivative-based focus measures. So variance of gradient, VOG, and squared gradient achieve the highest overall scores of 26.6 and 26.28 respectively. VOG and squared gradient are clearly the most dependable metric for focus tasks like blood film analysis. GLCM contrast and sum modified Laplacian can be considered where computational efficiency or focus range is prioritized. And now in these tables, I have also put the other focus, our matrices: accuracy, range, false maxima, and width at 50%. From these tables, we can conclude that variance of gradient and squared gradient emerge as the best overall performers. And the energy of gradient and Tinograd offered balanced performance throughout all these tables. Moving on, the GLCM contrast and sum modified Laplacian rank high in accuracy but were less consistent in handling false maxima. VOG and squared gradient energy of gradient demonstrated best ranges, ensuring reliable focus detection across different layers. H density exhibited the least false maxima, 0.67, followed by VOG and squared gradient. And in this graph, I have showed our best performer, variance of gradient, how it performed, how the curve fit of variance of gradient have performed in the 3 data stacks, our 3 data sets. Moving on, we also have to compare how our top performers work with the sinusoidal image stack, focus image stack, and the defocus stack. From that table, we can see the variance of gradient consistently ranked first or second across all data set, demonstrating its reliability for sinusoidal, focused, and defocused images. Squared gradient is excellent for defocus heavy application but slightly less convenient, consists of overall scenario than VOG. Energy of gradient maintains solid third rank across all data sets other than one, showing good consistency and noise resilience. Brenner gradient and GLCM contrast are solid general purpose metrics but less competitive for high precision applications. So at the discussion, we can say that derivative-based measures outperformed both statistical and histogram-based approaches since 7 of the 8 best performers were derivative-based focus measures, capturing fine structural details. They are well suited for blood film microscopy due to their precision and robustness. As we can see, the derivative-based measures are better in edge detection or detecting a lot of local maximas if the image from the image, and the statistical based methods have been robust in noise robust with noise, and also statistical based methods are computationally efficient, and the histogram based methods, as we have seen, mostly can be compared with the total contrast of the total image, and the computational efficiency in the derivative-based methods performs advantages come to slightly higher computational cost, which can be consideration for real-time applications. Then moving on to the conclusion, variance of gradient and squared gradient are the most reliable focus measures. Derivative-based technique consistently outperforms other 2 methods, and as the future works, in this research I only compared single focus measures, but in future, I am hoping to do combinations and try for more efficiency, and try same methodology with image pre-processing process like image subsampling, low-pass filtering, and adding noise to different brightness levels. Thank you very much. I'm up for questions.
Okay, thank you for your presentation. So now it's the time for questions.
Thank you for the good presentation. I think the comparisons were very detailed, but I also want to know how your work actually compares with the state of the art for blood film microscopy with other researchers.
Yes, sir. The thing is, for blood film microscopy, this was something I came upon. The problem research gap was something I came upon. There is no metrics that is being shown where we should use this metric for blood film analysis. There is no research. So with that research gap, I thought I should start creating a solution. And for this is one of my problem from my MPhil. So I thought maybe maybe I should introduce a focus measure. There are focus measures, lot of focus measures, but specifically for blood film analysis, they have not presented any paper. There are equipments, but they have not presented any outcome or what should be used for the blood film analysis. That's why I use this one.
Next question is now, we have a certain overall scores for different techniques that you have used, but I would also like to get a feeling about maybe the computational complexity of using different type of techniques to evaluate this.
Yes, so for the final algorithm, I will be only using from this research the variance of gradient only. So if you are talking about the computational efficiency of different focus measures, then the derivative-based techniques, it actually compares, let's say, every pixel density. They check the change in every pixel density. So that's how they check the edges. So it is very computationally inefficient. No.
So what is the resolution you are using for the images?
Images, we couldn't get very small. When we are resizing, we couldn't get to 256 to 256. So I had to go back to 512 to 512. 512, we could actually come up with good solutions.
Right. Okay. Thank you.
Thank you for the presentation. And my question is, you have selected 4 or 5 different criterias to evaluate, and you mentioned that it is kind of, are they weighted according to?
These are from literature, sir. These are the things.
Not these performance criteria, hang on. Yes, these 5. So when you calculate the overall score, right, okay, you use.
I used all these things, and for the ideal accuracy, it is 0. And the ideal range should be the maximum range of all things. And the ideal false maxima should be 0. And ideal width should be the narrowest width of all the focus measures.
I see. Okay. And so you compared the focus with the correct focus in there. You have shown a multiple number of graphs. So how do you determine the correct focus? From where do you get the information related to correct focus?
In the data set, how I get the data set is I corrupted 2. So the sinusoidal images I generated, since they look like a cell structure. And what I do is I put them at the 0th position, and I create 20 focus, 0.5, 20 stacks. And for the for the plus side, and for minus side, another 20. And same thing goes to the focus blood film images. I create with the Gaussian blur. I create 20 stacks up and 20 stacks down. And for the defocus stack, they already give us at the 7th position is the most focused one. And see, for first to 7, it is gradually getting incrementally up to the near focus position, then incrementally defocus. So at the middle is the correct focus position.
Understood. Right. Thank you.
Right. Okay. Thank you very much. Okay. Let us move to the next presentation. Development and mechanical characterization of particle boards from water hyacinth, a sustainable approach to invasive species utilization, authored by GGP SBK Dharmaratna, WDC Veerasinghe, DGWT Jayalath, and JDC Priyamantha.
Okay. Good morning, all of you. I am GGSBK Dharmaratna from Rajarata University of Sri Lanka. Okay. Development and mechanical characterization of the particle board from water hyacinth. This is our research. Let's move to our introduction. When we talking about the introduction part, we have to talk about our key identification of the challenges. Main challenges is reforestation. Deforestation is the main point in our Sri Lanka. Also in our world, we have faced lot of problem, global warming, and lot of environmental problem. what are the, we have opportunities. We have one opportunities for the reduce that one. It is the water hyacinth. We identified the opportunities as the water hyacinth. Why? It is the invasive aquatic plant in our country, normally called Japan Jabara in our country. Okay, and also, what do you think about water hyacinth? Water hyacinth mainly attack our irrigation system and also cultivation system and also fishing industry and also reduce the water dissolved oxygen and also degrade the water quality and a lot of attacks to in our environment. Therefore, we want to reduce it by using this solvent. Our key challenges and opportunity to plus together we decide the produce particle board from water hyacinth. Yeah, this is our main objective. This invasive plant, we want to produce the value-added product as a as a particle board. This is our main objective, and we have to improve the mechanical properties and physical properties this board, and also we have to identify what are the method and what are the how to improve that method for the mass scale and industrial applications. That thing is another objective. Yeah, this is our materials and method. When we talking about the materials and methods, we are talk about the 5 methods. This is the collecting raw materials, drying process, and after that mixing process and pressing and curing process. When we talking about the collection is the raw materials, we after collecting we have to wash and chop, and this is the main part. And also drying process, we dry our raw material in the sunlight. After that we mix with urea formaldehyde, and after that we are pressing by using mold. After that we have to cure. We can talk our method in detail. We have to collect raw materials in to the spread in some tank near to our university area, Kalattava and Mahakanadra tanks. We went to that tanks and we collect that materials, and after that we have to process. Firstly, we collect. After collect, we have to cut according to our samples chip ratios. After that, we have to dry and we have to mix with binder. After that, we have to press in. This is the secret point of this research. We have to press under the hot pressing. We use the mold for that and also hydraulic jack. After that, we can produce the particle board. And when I am talking about the hot pressing method, it is the hot pressing method is a very productive pressing method in this. In this method, we use for hot pressing method. We can use the particle board producing method for that, and also we use the chopping method, traditional mortar and pestle for this. When we talking about the results and discussions, we compare the our particle board under the standard ASDM D50 standard in the tensile strength, water absorption and bending strength. This graph this graph display the water absorption and in strength versus to pressing time. We can see the good pressing time is the 45 minutes, and also this batch 2 represent, we check the curing time versus to strength, and also 25 days, 25 days display the good mechanical properties, and also after that we check our mechanical properties versus the chip size. Chip ratios is the chip ratio is displays the good mechanical properties under the 1:1 chip ratio. Okay, when I am talking about our key finding, we make a particle board from water hyacinth, and we we can produce the alternative particle board using water hyacinth, and also we find the 45 minutes for the suitable pressing time, and 25 days for the curing method we suitable for this particle board. And also we find the eco-friendly and sustainable development we can do by using this board. Okay, when we talking about our future works, we can apply for this board for the partitions, and we can do some architectural works like this boards. We can use for the designing applications and lot of things. And we try to develop this method to entrepreneurship, and we try to develop this method for the spread in our country. And also we get the patent. Yesterday, we registered for the patent, and we achieved the patent for this method. And also, we try to develop this method for the apply in our country for the entrepreneurship. And also, we think about this board compare with another controller with positive controller and negative controllers, what are we can do and what are the mechanical properties. When we go to this part, we do the test part for this board. We couldn't try to do the test part for the controller, positive controllers. We try to do this thing under the future works. And also we want to do compare with this type of the boards, and we want to add some natural bonding for this one. And also we try to we try these days cost calculations, and we identify what are the cost for this one, and we want to develop low cost particle board for this thing. Okay, thank you for all the attend these presentations. If you have any questions.
Yeah. So thank you for your presentation. Questions?
Is the patent granted already, or have you simply applied, filed the application?
Patent granted.
Granted, certificate received?
Yes.
Okay. So what is your plan on commercializing the thing?
These days I am doing the cost calculations, and what are the, we find some people for the granting this industry, and I want, we following some industries how to develop that thing, and we want to develop this one, and we want to sell this product.
You are yet to set up a factory actually?
Yes.
Okay, thanks.
Thank you for the presentation. I have quick questions. First one is, what are the other plants that can be or may be used for this kind of board creation? Are there any other plants that can be used?
No, sir. We only use for the wood chips for that particle board. We in our country 483 cubic meters per annually used for the particle bead. It's the very big biggest amount for the wood. Therefore, we can use this one. Our country no use for the any other plant or any other material for the produced particle board. We can use the, and we suggest to new applications for the banana stem. It is going on new research as a new research, and we can produce the particle board also banana stem. We are these days we are following that one.
Okay. My next question is, have you compared the strength and other properties with the regular boards?
Yes, sir. These days I am doing this one, and also we comparing these days, but we couldn't add that data to this paper. But that our board is strength in high to rather than other boards.
Yeah, then definitely you should show that, right? The comparison between the existing ones versus your one.
Yes. This research only do for the we can do, or we cannot do this by using this plant. We can for the identify, we can do the particle board by using water hyacinth. Therefore, only test with this board. These days, we try to compare in others board.
Okay, thank you.
Thank you for the nice presentation. And my question is regarding the shelf life, because I believe your plan is to use these boards as kind of storage containers.
Yes.
So my concern is that, have you considered about the moisture absorption or the natural degradation of the boards?
Yes. FutureWorks, we under the FutureWorks, we are talking about the water absorption. We mainly particle board have drawback in the water absorption. It is, and also after water absorption, fungal attacks and microbiome works in the board. Therefore, we want to reduce it. All particle board in wood base and MDF board, all wood-based particle boards and other boards have main drawback is the water absorption. We try to add the natural bonding agent for that. That is the main reason is the urea formaldehyde. Urea formaldehyde absorbs the water, therefore that's the board highly degrade. Therefore we try to these days find trees latex for add this board. After that we can produce the full eco-friendly particle board without water absorption, low level water absorption. And also these days I am working as a bioprocess department for the as a research assistant. I am doing another research in the fungal attacks and what are the microbiome works in this board. These days I am trying to add some repulsions for the fungus and microbiome attacks. These days doing that thing.
Thank you. Have you considered about when you, I believe you are planning to commercialize it. So when you decide the cost or whatever the amount that the customer is going to pay, yes, have you considered about the energy requirement?
Yes. From
the beginning of like extracting the plant,
yes,
until you completely produce,
yes,
the board?
Okay. We these days trying to cost calculations, and also
not the cost calculation, the energy calculation. Right. Your process requires, yes, pressing, yes, step as well as drying step, and energy means money. Yes. So have you considered about the amount of energy that is required?
Yeah. I mentioned earlier this plant also very terrible attack to in our irrigation system. In university areas, tanks there's plant collect in some people in the and no doing some value added product. Therefore we can do that thing for use for it. And also then Mahakanadarawa tank have some boat for collect this plant. We can use the low energy for that. And pressing time, when we talk about the pressing, we particle board using high pressing energy, and also this board need that pressing energy. I think you mentioned earlier.
That's fine. It's okay.
Calculate the energies.
Thank you.
Okay, thank you for your presentation.
Thank you.
So let us move to the next presentation. Wi-Fi CSI based region detection for adaptive video compression and localization, authored by Yashindan Radhakrishnan, Jasmine Karki, Manoj Kumar Lenka, and Ayon Chakraborty.
So, good morning, everyone. So today I am going to present my work during the research internship at IIT Madras. So this is titled as Wi-Fi CSA based region detection for adaptive video compression and localization. Myself, Yashindan Radhakrishnan, I am from Electrical Electronic Engineering, University of Jaffna, and I have been collaborating this work with IIT Madras during the research internship. So I will be beginning with the introduction and motivation. So this will be a vehicle surveillance camera based capture. This is a 1 minute length of video I have set to 4x speed. So 15-second video, but because of the time constraint, I'll just So the video is not playing. So I'll tell that in this video I have observed 3 regions like 17 to 23 seconds, 27 to 31 seconds, and 56 to 58 seconds. So there are actually 14 seconds of it means there are actually 14 seconds of inactivity has been observed, because this is a vehicle surveillance kind of capture. Because in the vehicle surveillance camera, the primary task is to capture the vehicle motion or the people motion. So actually there's 14 seconds, it means around 20 to 30% of the time there's actually inactivity has been observed. So these 14 seconds I am considering as a window of opportunity. It means I can do something to get rid of these 14 seconds to only keep the region of interest in our video. And also some other non-interested parts also there, like these trees and also the skies and sidewalkers while capturing the video frames with the vehicle surveillance camera. So we'll discuss how can we get rid of those kind of things. So here, as you can see, this is a surveillance camera, and in normal scenario, this vehicle surveillance camera will be capturing raw video frames, and it is trying to transmit all raw video frames into cloud-based services. In the cloud, we can able to do some videos analytic tasks like occupancy detection, vehicle classification, and number plate recognition. But what our proposal is, we don't need to send the raw video frame. Instead of that, we can able to detect the region of interest, and we can keep the region of interest at high resolution, and we could able to quantize the non-region of interest parts. In this scenario, we are going to convert this video surveillance camera into intelligent video surveillance camera, which could able to automatically detect the region of interest. But there are existing region of interest detection, like getting the video frames and analyzing each and every video frame with the image processing deep learning techniques. But we are not going to use that one, because basically when we are dealing with the image, it's typically larger in size. Example, so 1280 cross 720, it is typically high. But we are not going to use that method. Instead of that, we are proposing a Wi-Fi channel state information based method. Let's keep it that in a side, so I'll explain that in the upcoming slides. So if we are using that kind of method, then we could able to decrease the hardware resources and energy usage. And also here we are going to transmit the quantized video frames, which is lesser in the storage, so we could able to decrease the network bandwidth usage. So if we are decreasing these 3 things, then cost also will decrease without impacting the accuracy, because we are keeping the region of interest still at the high resolution. So we can able to still do these kind of activities at the cloud. So we are not going to impact the accuracy. So let's talk about this region of interest. I have marked, so I have showcased 5 images. In the 5 images, I have marked the region of interest. So we have to keep this region of interest at high resolution, and we have to quantize other parts. Let's see how to do this. So quantization in the sense, it is having a scale of 0 to 51. As we increase the quantization level, you can see the blurred thing is increasing, so we can able to reduce the storage while increasing the quantization. This can be achieved like tools like Kavazer and all. So let's understand how this Wi-Fi channel state information can be used as a sensing modality. So let's first understand how this Wi-Fi signal is propagating to the multipath environment. Basically, if we are having a Wi-Fi transmitter and Wi-Fi receiver, the Wi-Fi signal is going to propagate through the multipath environment. And each and every signal will have its own time of flight and the attenuation. Then we can use this one to get this one. It means here I have the Wi-Fi transmitter and receiver and these signals. Then we can able to get the channel impulse response, which is drawn time versus amplitude. This is the channel impulse response. Then we can able to do the FFT to get the channel frequency response. So this channel frequency response is particularly got by analyzing only one Wi-Fi packet, and if we stack together multiple CSI packet, multiple Wi-Fi packet, then we can able to generate this kind of channel state information spectrogram. This is I have showcased frequency versus packets. So frequency sense, in our example, we have used a Wi-Fi with 20 megahertz. Then there will be 64 OFDM subcarriers. Each will be having different frequencies, different amplitude. If the obstacle is changing in the particular, so it means in the video frame, if the vehicle is changing one position to another position, we can able to get different CSI patterns. So based on the CSI patterns, we can able to point out which part the exact vehicle is present. Then other part we can able to simply quantize. That is our idea. So this is our system overview. Here, this is the road. Here we can able to place our access point. This is a vehicle surveillance camera, which we can, here also we can able to place the receiver. And from here to here, we can able to collect the Wi-Fi signals, and which is, so here we can able to get the CSI. At the parallelly, it is capturing the video. So this is a particular video frame, correspondingly, this is the CSI. So this CSI can be used to generate the ROI, and this ROI in this and this video combinedly used to do the HVAC encoding with the Kawasar tool, which will be giving the compressed video. And with the input of the CSI and video, we can able to get the output as a compressed video, which could able to pass to the cloud, and we can able to do this video analytic task. And this is the architecture of the approach. The inputs are Wi-Fi, CSI, and the video. This Wi-Fi CSI is going to generate ROI. This video and ROI is going to be encoded and getting the compressed video, and we can able to do the analytic task in the cloud. So before applying this into vehicle surveillance camera, we have did this for checking different activities. So as you can see, different activities have different channel state information patterns. So similarly, we can able to use this for the vehicle surveillance camera, which will be giving the different patterns for different vehicle locations, and we can able to point out the region of interest, and we can able to quantize other parts. So this is the setup I have used. I have used 2 laptops and 1 access point, and this I have used the IPOV server and IPOV client to increase the traffic in a particular channel. And I have flashed the next mount called firmware, open source firmware in a Raspberry Pi. And while flashing that, the wireless interface got killed, and I have used the Ethernet interface here. And here I have done the wireless SSH and Ethernet SSH, and here I am capturing all the Wi-Fi signals. So here the region of interest is going to be getting, so we can able to use it for the quantization purpose. Here one set of, so this is the outdoor setup we have done at IIT Madras, and this is a router AP, and here I have placed 2 laptops, and this is the receiver part. The receiver part I have used 2 Raspberry Pi, one is flashed with Nextmon and other is a simple OS, and I have used the batteries. So I have done this experiment setup in 2 scenarios, one in the outdoor and one in the indoor. The indoor also I created similar setup of traffic surveillance camera. So here I have marked 3 regions. If the person is in here, we can able to quantize these 2 parts. And here, if an obstacle is placed in a particular location, we could able to quantize other all 8 parts. So these are results. So 3 and 4 classes results means in the outdoor I have taught that there are 3 regions, but with the empty there are 4. So with the 3 class classification, I got accuracy around 80%, and flow class I got accuracy around 72%. And with the 9-tile experiment with the empty room, there are 10 classes of classification, and I have got accuracy around 95%. And these are the data I have collected in each tiles, and with the naked eye, we can able to distinguish from one pattern to another pattern. Then this model will work better in a particular CNN-based models. This is my ultimate results. So if we are considering this, so this has drawn for foveated area versus value decrement in the percentage. And if we are considering this as a ground truth, and if I am increasing the quantization parameter of the foveated area, we can able to see that bandwidth decrement and the energy decrement significantly high. It means around 60 to 80% of the bandwidth decrement and energy decrement we could able to achieve with the minimal accuracy loss around 10 to 15%. So this is our ultimate results until this point. So the conclusion and future work, we have developed a low-cost Wi-Fi sensing modality, and we have got good region of interest estimation, and around 60 to 80% of savings in the network bandwidth we got with the minimal accuracy loss of 10 to 15%. The future optimization we are considering with the Wi-Fi signal, we could able to classify the vehicles, and also I have got some results like if the vehicle is passing, then there's a gradient in the pattern. So with the gradient, we could able to get the speed estimation also. So this is the future work that we are planning to do. Thank you.
Okay, thank you for your interesting presentation. So the questions time.
Thank you for the presentation. I have a couple of questions. First one is about the background of a certain image. So how does your technique adapts when the background also like changes, maybe due to lighting condition changes, then this quantization
Light,
will...
yes. So light, I think a lighting condition will not impact because I think some bad weather can be impact this kind of situation. So I have considered that also. We need to like train the model with the bad weather condition also to give proper result in all the conditions. So until now, we didn't consider that bad weather condition and all other situations.
Right. My next question is about the line of sight that you have mentioned. So what was that? Is it for this one?
So here it's no need. So yes. So this is the access point and this is the receiver. So this no need to be a line of sight. I just indicated this will be a line of sight. So anywhere in this part we can able to get the different pattern. So if the person is moving in the line of sight, then shadowing effect will be there, then amplitude decrement will be there, so we can able to see the clear pattern. So that's why I marked this line of sight.
Okay, so there is no hard requirement of having line of sight here.
There's no hard requirement.
Okay. And one more. There were 3 classes. So how do you scale for more than 3 classes?
This indoor, like, so why I consider only 3 classes? So in the outdoor, it's open area, so I couldn't able to get high packet rate. But in the inside of the room, because of the reflection, so all the packets are inside the room, I can able to get around 400 packets per second. But in the outdoor, I only get around 150 packets per second. So that's why I couldn't.
But the real application is in an outdoor environment.
Yeah. So outdoor environment up to 4 classes, like it is giving this much accuracy. Now I need to like increase the packet rate to like do some extra like classification, like 3x3 or 4x4.
Right. Thank you.
Thank you for the presentation. Actually, my question could be an extension of what Dr. mentioned. So since it is an outdoor unit, it has to be an outdoor unit, and you did a kind of a study related to the savings in slide number 17. The savings that you can obtain by implementing this. The savings in, see, slide number 17.
This one?
Slide number 17. Yeah, the savings in network and energy resources. Okay, so you mentioned that the number of packets that we are receiving is about 150 at the moment. So in order to increase that, you may have to incorporate a little bit more equipment, as well as, because you are implementing something new, so you are going to add more equipment to the system, okay, in order to save a certain amount of energy, storage and stuff. So here, have you considered about the amount of cost that you need to incur when you are installing the additional equipment required in your system?
So in the existing system, the Wi-Fi access point is there, because anyhow we are going to transmit all the collected video frames to the cloud. So only the requirement is we need to place the receiver at different location. For the receiver, currently I have used the Raspberry Pi, but I think I can able to do it with the ESP32 also. So with the different microcontroller, I can able to further reduce the cost. For the initial testing, I have used the Raspberry Pi. So only the requirement is additional receivers only.
In your case, you mentioned that in the outdoor, the amount of packets you are getting 150.
Yeah.
So what is your plan in order to enhance the number of packets that you are going to receive?
Currently, like I have used 20 megahertz Wi-Fi, which is like giving 64 FDM subcarriers. So if I increase it to 40 or 80, then the number of subcarriers will be double. So in that scenario, I need to like analyze with 124 subcarriers. If I can get more number of details, then with that 150 packet rate, and I can be able to achieve the same thing. So I need to use different Wi-Fi standards.
Okay. So does this change can be implemented with the current Wi-Fi system that they are currently using, or do you need to do certain modifications?
In the access point, we can able to log into the access point and simply we can able to switch to 1 megahertz to the other megahertz. So we don't need any additional things. So just as.
Okay. Okay. Thank you.
Okay, thank you for your presentation.
Thank you.
So let us move to the next presentation. An investigation into the role of ergonomic and safety-focused design in construction, analyzing its impact on project success. Authored by K. Waiteki.
Good morning, all of you. I'm here to present about an investigation into role of ergonomic in and safety-focused design in construction and analyzing its impact on project success. The construction industry is the most hazardous industry in which workers face huge amount of risk regarding injuries and illnesses compared to other industries. The rate of injuries in construction is almost double in construction industry, more than other industries. Ergonomic is a science which consider about design of spaces and workstations to improve the workers' comfortability and reduce musculoskeletal disorders and reduce physical strain of the labors. The ergonomics which consider about the engineering and psychology, human physiology factors and sustainability factors to improve the design requirements of the and functional requirements of the workplace. It can be applied not only in the construction sector but also into the other sectors also. The ergonomics can help the workers to overcome the issues which related to heavy lifting of the materials and awkward postures and repetitive movements which faced by the laborers. These advanced tools of ergonomics that will reduce the physical strain and musculoskeletal disorders faced by the laborers, and that will improve the health and safety issues to the construction workers. And according to the previous studies, the ergonomic intervention help to reduce the musculoskeletal disorders and injuries by 40%. The ergonomic application not only improve the health and safety of the laborers, but also it reduce the absenteeism of the laborers, and also it reduce project delay as well. The aim of the research study is to investigate the design strategies for construction site that focus on the ergonomic safety and productivity in construction industry, and also its impact to the project performance. The objectives of the study is described as follows: to evaluate the existing design in construction site with respect to ergonomics and safety compliance, to assess the design strategies in construction industry which particularly concern about ergonomic safety and productivity, and also evaluate its impact in the construction performance. And the third objective is to examine how ergonomics application improve the project performance in terms of schedule adherence and then cost control and quality improvement in construction sector. The scope of this study, which is limited to the application of ergonomics in site tools and site workflows and layouts. The ergonomic in construction industry can be applied in several ways. For example, ergonomic application can be applied in interior design of construction or exterior design of construction. Ergonomics can be improved the functional requirements in the construction sector, and also selection of interior design, colors of the interior and design of the interior, elements of the interior design. Also we can apply the ergonomics. For example, for kitchen design, we can use a triangle placement of the kitchen sink and then refrigerator, and then that kind of things we can make it triangle to reduce the workforce and physical strain of the workers in the kitchen environment also. The literature review, the objectives of the study was achieved through the comprehensive literature review, and this literature review mainly focused on design of existing ergonomics application and safety focused application in construction industry, and also it assessed design of ergonomics application with regard to safety and productivity in construction sector, and also the impact of ergonomics in project performance with regard to schedule adherence, cost control, and project quality. Then research problem. The aim of the research study is to investigate the application of ergonomics in terms of construction industry and also its impact to project performance. This research study filled the gap between theoretical applications and practical application of ergonomics in construction sector. The application of ergonomics in construction sector and its impact to project performance is the most important topic to investigate. There is lack of research studies carried out under this topic. Materials and method. This research study objectives was achieved through a comprehensive literature review, and the data collection was done by referring journal articles, conference proceedings, websites, and scholarly publication, case studies, industry reports, and then the data analysis was done by thematic analysis process. The objective one of the research results and discussion. The objective one of the research study have the following key findings. The ergonomics in construction, which aim to design task, equipments, and process, which is to fit the workers' requirements, which is most suitable as according to the workers' physical capabilities. And it's according to the workers' psychological factors also considered in the work ergonomics in applications. Effective workstation arrangement that will reduce the musculoskeletal disorders by 25%. For example, effective workstation arrangement, that means adjustable tables or adjustable scaffolding arrangement, that will reduce the physical strain of the laborers, and also it will reduce musculoskeletal disorders, and that is used to maintain the neutral postures of the laborers, and that will reduce the musculoskeletal disorders by 25%. And the next one is proper personal protective equipment storage, and that will reduce health and safety injuries by injuries also. Easily accessible and easily storage personal protective equipment boost the employees to use it daily work environment, that will reduce the injury rate by and reduce the likelihood of the accidents. Then ensuring easy access to equipment, that boosting the employees to use the personal, that is boost the and reduce the physical strain of the laborers, and reduce the musculoskeletal disorders, and reduce the unnecessary movement effort faced by the construction workers. And then the compliance of local and international safety regulation, that means the OSHA mandates proper fall protection system, training of the laborers, that will improve the health and safety of the construction and reduce the hazardous risk of the construction environment. The objective 2 of the research study is to exploring the design solution, prioritizing worker safety and productivity. This ergonomic gear, such as mechanical aids, adjustable scaffolding, lowers the injury rate by 30%. This design of adjustable scaffolding, that will facilitate the laborers with different heights can easily work without any physical strain. Then clear signage and accessible personal protective equipment, that also boosts the employees to work easily without any injuries and accidents. And then incorporate safety measures at initial stage, that means to avoid the working and height requirements. But for that, they can use prefabricated components and ground level assembly process, that will reduce the working and height requirements and reduce the risk rate. And then technologies like augmented reality, building information modeling, that will reduce the accidents, injuries by 40%. Building information modeling that help the employees to identify the issues of health and safety issues at the early stage of the project. And then next one is objective 3 of the research study is to examine the impact of ergonomic design in project performance. This ergonomics application will reduce the injury rate that will lead to 15% increase in project schedule adherence. For example, the ergonomics application not only improve the health and safety of the laborers, and also it will reduce the absenteeism of the laborers, that reduce the project delay also, and reduce the loss of workforce due to the accident. The time spent for accident also reduced, so that will improve the project adherence by 15%. The ergonomics will decrease the cost of the construction by 30%. That by implementing the ergonomic application, that will reduce the medical expenses which arise from any injuries, physical strains, and musculoskeletal disorders also. And here.
Okay, now is the time for questions. Thank you for the presentation. I have one question. Now, from what I understood, this is like, as the title also says, it's an investigation into the role of ergonomic, mainly talking about the posture of the workers and so on. So is there an experimental phase involved in this study? For example, if a worker is doing a bad posture, then some corrective suggestions are coming in. That kind of an experimental phase is involved in this study, or is it only a literature review and study on it?
This is only based on the literature findings, but I suggest that experimental for future research areas I suggested. Yeah, this is only based just only the literature review.
Right. Thank you. Okay.
Thank you for the presentation. And I have two questions related to your objective 2 and objective 3. The objective 2, I believe it is related to the design solutions. And have you identified the design solutions which are critically important for the construction industry in order to enhance the ergonomics?
Yes, that design solution that is important to reduce the workforce which is spent by the laborers, and also physical strain, reduce musculoskeletal disorders faced by the laborers.
Any examples that you can provide from the construction industry specifically?
By using that moving that scaffoldings, adjustable scaffolding, that will reduce the physical strain when working for the painting works or plastering works. They can reduce the physical strain which spent by the laborers. That kind of examples. And then moving tables, so that when lifting heavy equipment, so heavy materials, they have to maintain some kind of postures. Ergonomics suggests some kind of postures. Here in this person bend his hip, that is not needed, but according to ergonomics, no need to bend his hip for carrying any materials from the land. Okay.
Then in objective 3, you mentioned that you are going to evaluate the impact of the project performance. And I believe you have shown some numbers also there, like 20% enhancement, 30% enhancement, something like that. I believe those numbers are actually coming from the literature rather than a study conducted by you.
Yes,
what is your plan on actually evaluating those values if you are actually happen to have this kind of a study in an actual construction project?
Oh, if for any experimental related to studies, I have to give a questionnaire survey or conduct interviews to the project participants and get the data from them and to develop furthermore.
From the study that you have conducted, have you come across certain key points that you might include in such as questionnaire?
Yeah, so in that questions I can mention what is the percentage of schedule adherence, improvement in schedule adherence from this ergonomic intervention in construction. I can include that kind of questions.
Now, the question is actually you are going to give the questionnaire to the workers. So what kind of information that you can obtain from the workers?
From workers, then closed-ended question we can give them and get their feedback, how they improve how that ergonomic intervention improve their comfort level, very high level, moderate level, or low level.
My question is related to the project success. You mentioned the objective 3 is related to
yeah.
So,
what
you are mentioning is
for
about
project success, we have to get the questionnaire surveyed to construction professionals, quantity surveyor, engineer, project managers. They will only answer about that kind of things. Yeah.
Do you have any idea about what kind of questions that you are going to raise there? From
we can ask what is the percentage of improvement. We can ask the improvement level of the ergonomics intervention in construction industry. They can mention very high level, low moderate level, low level, very low level. Closed-ended question we can give likewise. So any interview question also we can ask from them. But other suggestion you can give to improve the ergonomic solution to labor working environment likewise.
Okay, thank you.
Thank you.
Okay, thank you.
So let us move to the next presentation. Cloud gaze Landsat sky image based determination of cloud motion to predict solar obscuration. Authored by C.R. De Silva, W.M. Vimalasiri, S.J. Suryarachi and H.H.I.N. Gunaratna.
So good morning everyone. I'm going to present on the project title Cloud Gaze. So as the project title says, a Landsat sky image based determination of cloud motion to predict solar obscuration. I'll walk you through about the project title, paper title, as we move on with the slides. And to talk about the problem domain of the title domain, let's dive into the title of solar forecasting. What is solar forecasting? Solar forecasting is about predicting the amount of solar energy that will be available at a specific location or a time. And so to get solar forecasting, what are the existing methods and what are the issues? One existing method is numerical weather prediction models. So these numerical weather prediction models, they use complex mathematical models to forecast and stimulate atmospheric behavior. So what are the issues? The issues that consist within NWPs are the lack of spatial and temporal resolution. It is computationally intensive, and it is based on these equation. So it can may lead to many inaccuracies. And another method another approach that exists in the car industry is the satellite-based solar forecasting. So as you can see, it can predict solar forecasting by producing collected data from weather satellites. So it also has this issue with spatial and temporal resolution, and there's a huge latency in data acquisition and processing, and there's difficulty in accurately modeling the cloud dynamics. And as you can see, these are simple graphics about how the project goes. All right. So in my approach, there are 6 steps. The first one is image capturing. Then the next one is image pre-processing, and then third one binary segmentation, 4 optical flow, 5 prediction and notification. let's deep dive into each of the steps. The image capturing. So in this image capturing step, I have used this setup. In this setup, as you can see in the top shelf, there is Raspberry Pi Cam 2, to get the virtual image that is from the sky, I have used the concave mirror and a power bank and a Raspberry Pi 4B. And to do the image pre-processing, as the images that are taken from the Raspberry Pi, there is a lot of noise. So as the pre-processing part, what I intend to do is I remove all the uninterested area that is the rod and that camera part, and next part is the noise. And the next part is for at the same time of the image pre-processing, I have removed brightest mask. That means the sun's area, and I have gotten, I don't know whether you can see the spot, but I have got the XY coordinates of the sun centroid. And the next step involves in binary segmentation. So there should be a method to segment the cloud regions and the sky regions. So I have used binary segmentation. But for this method, I won't be using any machine learning models. I have used this simple thresholding in HSV color space using two binary masks, the cloud mask and the sky mask. So in the same step as binary segmentation, I have marked all the cloud areas, and from the same intuition that we have in normal life, if a cloud will cover the sun, it should be the largest cloud that is on the image. So I have taken the largest cloud among all the clouds that I have taken from the contours, and got the centroid of that largest contour, that largest cloud. And the next step is calculating optical flow. Optical flow is a method used in computer vision to integrate the motion between two frames. So here I have used the method, the algorithm, Lucas-Khan algorithm, with the assumption of brightness constancy and small motion between the frames. And as you can see, this is a visual representation of how we can track the cloud behavior. From this is the t equals 0 frame, and this t equals 10 frame. You can see how the cloud pixels have moved from this picture to this picture, and it's not the use case in our scenario. So this is one of the, actually you can't actually see, there are some motion vectors in this image, but it's not very clear. That's why I have used the other slide. And from this step, in the same step as getting all the motion vectors, I have got the average vector, and I have marked it at the largest cloud centroid. And then prediction part. So prediction part is the novelty in this method, in this approach. So in the prediction path, what I do is, these are the centroids of large clouds within two respective frames, and this is the estimation that I have gotten from applying getting the motion vector from Lucas-Khan algorithm. And for our intuition, and we can say if the largest cloud centroid for two respective frames is the distance between the largest cloud centroid and the sun centroid, if the distance is getting low, then you can say there's a somewhat possibility that the cloud will cover the sun. So I have used that assumption, and now you can see in this method I have achieved 10 seconds of prediction. So here I have taken two predictions and two measurements and one estimate. So here again 10 seconds estimate. So I have to improve this method. So next, what I have done is I have used the Kalman filter to get the other predictions. So when I know if there are two respective frames that are going to cover the sun, and I have taken another estimate from the Lucas-Khan algorithm, then I use this alpha beta tracking on Kalman filter to get the other estimates. And and I can take other in estimates for the cloud center in respective frames. And this is a mathematics part that is there in Kalman filter. And this is the prediction algorithm that I have used in the project itself. So as you can see, it's nothing rocket science, just a normal flowchart. This is so after detecting if the cloud is getting closer, and I have used apply Kalman filter to get the predict the time. And daytime results. So for this step, what I have used is so I have taken frames at each 10-second intervals, and I have been able to get 40 seconds ahead of predictions. And for the notification, I have sent for this step, I have sent an email to the customer saying there will be a solar obscuration in this much of time. And why different? The different is in the why different in the sense of what is the novelty in here. The novelty is in the image capturing part, because no one has used this method to use this setup to capture the images. And this prediction is all done without machine learning. And so I hope you are looking for what are the applications that can be used in this scenario. First one is solar power optimization and renewable energy grid stability. And what I want to highlight is the how to utilize this in our domestic solar panels. So you can use that to integrate this in smart homes to adjust energy consumption, like dimming lights and delaying non-essential tasks during low solar energy periods. And this is a conclusion. This is an effective method I came up with to detect cloud motion and predict the solar obscuration. And these are the future works. The future work includes developing a prototype for solar ring panels, and this can be used to predict how much time it will cover the sun, and apply automatic thresholds with respect to the environment. These are the acknowledgements and references. So that's all.
Thank you for your presentation. So now is the time for questions.
Thank you for the presentation. I have a few questions. The first one is, so we saw your proposed method, but one thing that was missing is the literature review part. That is what other people have done regarding this particular work. Do you have any comments on that, where your work stands?
Literature review, so in the presentation itself, I haven't included the literature review part, but I went through some the references that are there on the presentation. I have went through those research papers and got this and used those materials to improve my method.
So did you do a comparison of your results with existing work?
Yeah, I actually did. I couldn't download the updated PowerPoint on the machine. So I used the machine learning like CNN to predict the solar obscuration, but at the edge it cost a lot, and never predicts anything. And if it's on board, it predicts very accurately. Those methods I have used actually. I have made those modifications, but when I changed now itself, I couldn't get into the presentation.
Yeah. So since you are saying you are using computer vision techniques other than machine learning. I think that's why we really want to see the comparison between other techniques and your ones in terms of accuracy, maybe the computational. So for the future, please do that. The next question is the camera like pointing upwards, looking?
No, pointing downwards, sir. Here, pointing downwards, sir. So what you can do is, here, I make a virtual image of the sun on the concave mirror, and I get I capture that image, sir.
So what if in a scenario where we have direct reflection from the sun, will that be a problem, like too bright for the image?
The sun rays will damage the sensors in the camera, so I have used that method, but the resolution I get from those images are not that clear, sir. So that's why I use.
So we have such situations also, right? There are times we have clouds, then we have clear sky. So in that scenario, what happens?
Actually, did this work for where the sun is there, because for the applications that where there are no clouds in the sky, so I haven't used that use case. So I haven't gotten results for that use case.
Right. Next question is regarding optical flow.
Optical flow.
We normally use it for kind of odometry detection in small, like short-term horizon. But when it comes to this kind of research work, I think we need to have a broader horizon where we want to predict the motion of clouds for not just, let's say, 1 or 2 minutes, but for the for the whole maybe 1 or 2 hours. I think that's where the applicability of this work comes into in terms of like solar power optimization or that kind of thing, right? Not just short-term horizon. And maybe, thank you very much. That's it.
Thanks, sir.
Thank you for the presentation.
Thank you, Dr.
I have one question related to the cloud. You mentioned that you are taking the centroid of the largest cloud.
Yes, sir.
What happens if the shape of the cloud changes?
So to apply the Lucas-Kernel algorithm, you have to assume that all the pixels that were there in the previous image, that will be there in the next image. Otherwise, without that assumption, sir, I can't do any predictions, or I can't do any estimates beyond that point. So I have to maintain that assumption. So
yes, I mean, true that you can maintain an assumption, but in the real life, if that really happens, will it? I mean, it will affect the accuracy of. Have you?
So what I've noticed is I have come up with this time interval with the trial and error method. So I have tested for 30 seconds, 10 seconds, 5 seconds, and that. And I have noticed, I didn't actually include those results. And what I noticed is with the 10 frame, with the 10 seconds window, I can get a good picture of the motion. So that means there won't be any escalated motions, or there'll be a steady flow within the 10 seconds window, sir. Not like our motions, the clouds move that not that fast, sir. So, yes.
Thank you.
Thank you, sir.
Okay, thank you. So now we have come to the last presentation. Low-cost implementation of an autonomous navigation robot with LiDAR for educational robotics using Raspberry Pi, authored by Sanjula Gatsara and Sulochana Suryarachchi.
Yeah. Good morning, everyone. So I'm going to present the low-cost implementation of autonomous navigation robot with LiDAR for educational robotics using Raspberry Pi. So the objective is to make a robot that is capable of navigating with a LiDAR and also using a Raspberry Pi in a low cost. So this is the objective. So these are the current solutions that we have. So if we want to make a robot, let's say if we have a use case for educational point of view, if we have a student that wants to learn the navigation stack and also LiDAR and those kind of things, if we want to buy that robot, this is the cost that we have, like 180,000 rupees and 150,000 rupees. These are the costs that we have in the market right now. So this research that I have done is with the collaboration of University of Malta, Department of Computer Science and Engineering, and with the company called Robotic Gen. Those are focusing on educational robotics. So they given me the task to make a robot that implements a low-cost approach for this LiDAR and this navigation parts that we can done in educational kind of things. So this is the system view. So in high level, so I'm incorporating Raspberry Pi, and there are some power supply units and also LiDAR and some stepper motors to control the system. So from initial design and my 3D modeling, and after the final design, this is the path that I have taken. These are the components that I have used. You can see there are 3 levels in my robot, and there are 2 stepper motors to drive the wheels. So I'm using the differential drive wheel mechanism, and also the LiDAR on the top to get an unobstructed view, and also this is the high-level view of my prototype. So first I've done 3D modeling of my proposed solution. So this is an image of that. And then I made the chassis using acrylic. And also I've designed the 3D print, designed the parts that can be made for every aspect of the design. And these are some prototype making things that I've done with acrylic laser cuttings and 3D printing technology. And these are some hardware testings that I have done. So in this LiDAR, we can have 4,500 hertz working ratio, and these are some testings I have done. And this is some software that I have developed to visualize the area. So this is you can see in this photograph, this is a room, a square room, and there are some chairs in there. So these are some sample visualizer that we can make with this robot. And this is the final product that I have made. So you can see that. And the results. So I previously said that we can buy these kind of robots like in this kind of amounts, like 180,000 and 150,000. So the thing that is most important in my design is we can make this to sell in 90,000 rupees. So this is the cost breakdown that I had. So in the cost, we can have the total cost of 67,000 rupees approximately. Then we can add a profit markup of 34% and get the selling price of 90,000 rupees. So yeah, that's about my presentation. Thank you.
Okay, thank you for your presentation. Now it's the time for questions or clarifications.
Thank you for the presentation. I have a few questions. Now, first thing about actually the choice of motors. I don't think a stepper motor is the right choice for this kind of a robot. I mean, for any kind of robot, I would say, unless you are doing some, precision control, and because we use steppers for, okay, go to a certain position and hold that. But here you could have used regular like DC motors because we don't use steppers as the driving motors. Is there any particular reason you used?
Yeah,
that is for continuous rotation.
So I get the stepper motors because we need accurate position control. When we are mapping an area, we need to get the accurate readings, how much we have gone and such kind of things. We could have used DC motors plus encoders for this task also, but I got this for open loop control and like ease of use for educational purpose of things, because I made this robot for education educational robotics. So
but you could
students
have reduced the price if you used a regular DC motor with a wheel encoder, right? Magnetic encoder or something instead of stepper.
And also the position hold that I can get from a stepper motor. So I can hold the position like we can have accurate torque control from this. So that's one reason that I got this from.
Yeah, but I still think you could have gone for DC motors. Next one is about the LiDAR. What's the LiDAR?
LD19 LiDAR.
LD19. What's the distance it can measure?
It can go up to 12 meters.
12 meters. Okay. And how many points per second?
4,500 hertz is the resolution. For we can get 4,500 points.
Which is manageable for a Raspberry Pi, right?
Yeah.
What's the frequency you are running? The
Raspberry Pi.
Let's say your autonomous navigation.
When I'm using the LiDAR for 1 second, I can get 4,500 points for 360 degree of view. So I made this visualizer to see whether it is feasible to make incorporate this LiDAR with the Raspberry Pi. So I got the results that I can use with this as well.
And what's the model of the Raspberry Pi?
Raspberry Pi, for this I used a Raspberry Pi 5.
5?
Yeah.
Okay, one last comment is regarding the slide that you showed, the existing ones with only 2 robots. So I would have liked to see many other robots, because there are so many robots that uses LiDAR with Raspberry Pi. So, okay, thank you.
Thank you.
Thank you. I have a question related to the costing at the end of your presentation. I believe the 2 robots there, which are 180,000 and 150,000, that includes everything in the manufacturing production process. In the 90,000 rupees here, have you considered about, have you included the effort that you have put there?
Yeah.
And the research and development cost, and basically, I believe those 2 comes with some kind of a warranty as well.
Yeah. I incorporated those parts in other overheads and cost that part.
So for 1 unit, you only need like 4,000 rupees for R&D, warranty, and everything.
Yeah, when we are making the mass manufacturing this, we can absorb the cost into that part. And also in this 90,000, I added a profit markup of 34%. So we can, if there are any more costs to add it, we can get from that also.
Okay, right. Thank you.
Okay, we have come to the end of the presentations. So let us give a big hand of applause to all the presentations. Authors. Thank you. Over to you, Prabhat.
Right, those were some very interesting and insightful presentations. So thank you for all our presenters today. So now I would like to extend our sincere gratitude to the panel of evaluators today. We do have a few tokens of appreciation. So I invite Dr. J.R. Gamage, the chair of ERU Symposium, to hand them over. First, our session chair for today, Dr. Kasun De Silva. Next, our distinguished panel members, starting with Dr. Lihil Subasinghe. Finally, Dr. Peshala Jayasekara. Thank you, sir. Next, we recognize the invaluable contributions of all our participants for ERU Symposium 2024. To present the first set of participation certificates, I invite Dr. Sulochana Suryarachi, the Director of the Engineering Research Unit of the University of Moratuwa. First, the paper titled Satellite Image Band Ratio Techniques for Identifying and Visualizing Mineral Exposure Zones in Kandy District, Sri Lanka, authored by R. Madhurshan, S.P. Chaminda, ABN Dasanayaka and WAM Fernando. Next, the paper titled Blade Pitch Angle and Camber Optimization of a Vertical Axis Wind Turbine Using Numerical Simulation, authored by NMIW Bandara, WMKS Veerasekara and SDGSP Gunawardana. Next, the paper titled Design and Development of a Bulk Cinnamon Processing Machine, authored by Ishara Sangeet, Shamishka Madhushan, Thanuja Dharana, and J.R. Gamage. Next, the paper titled Application of Random Forest Model in Google Earth Engine to Enhance Land Surface Temperature Estimation, a Machine Learning Approach, authored by K. Isith Keshara, R. Madhurshan, and RMNP Rajapaksha. Next, Autonomous Wheelchair Robot Navigation Incorporating User Expressions, authored by Tisara Patirana, AGBP Jayasekara, and BGDA Madhushankar. Next, Multi-Sensor Satellite Remote Sensing Data-Based Comparative Assessment of the Surface Water Level Dynamics of the Victoria Reservoir, Sri Lanka, authored by R. Madhurshan, KIK Dhananjaya, T. Kirthi, SM Dasanayaka, and Z. Chao. Next, benchmarking OCR models for Sinhala and Tamil document digitization, authored by Purushoth Velayudan and Thanuja D. Ambegoda. Next, water quality assessment in Madhuganga, authored by Janith De Silva, Harshika Ratnayaka, and Pubudi Dilshara. Thank you, madam. To present the second set of participation certificates, I now invite Dr. Kasun De Silva, co-chair for ERU Symposium 2024. Developing a sustainable and biodegradable packaging material from Mana plant, authored by Samaranayaka SATP, Lianage ULBS, Pereira TR, and Herath HMIK. Next, comparative analysis of autofocus measures for blood film microscopy, authored by Heva Vitarana DC, Jayatilaka WADM, Dasanayaka VPC, and Amarasinghe YWR. Next, eco-friendly and sustainable paper production from waste banana comb fibers, extraction, process optimization, and performance evaluation, authored by PWCLK Polkotua, WDC Veerasinghe, DHA Prasanna, and BL Madhuranga. Next, development and mechanical characterization of particle boards from water hyacinth, a sustainable approach to invasive species utilization, authored by GGSBK Dharmaratna, WDC Veerasinghe, DGWT Jayalath, and JDC Priyamantha. Next, the paper titled Automated Data-Driven System for Natural Rubber Coagulation Using Coconut Water as a Coagulant, authored by HPGPA Sevandi, PGMPB Pallegedara, SD Varthaseelan, Isuranga Nipun Kumara, Chamishka Ishani Rupasiri, Umal Nanamura. Next, we have the paper titled Wi-Fi CSI based region detection for adaptive video compression and localization, authored by Yesindan Radhakrishnan, Jasmine Karki, Manoj Kumar Lenka, and Ayon Chakraborty. Next, we have the paper titled An Investigation into the Role of Ergonomic and Safety-Focused Design in Construction, Analyzing its Impact on Project Success, authored by K. Vaitheki. Next, we have the paper titled Analysis of Factors Affecting Oil Weathering of Accidental Ocean Spills, authored by L. Kaluarachi, Ajit D. Alvis, and Injadit D. Nisanka. Next, we have the paper titled Cloud Gaze, Landsat Sky Image-Based Determination of Cloud Motion to Predict Solar Obscuration, authored by C.R. De Silva, W.M. Vimalasiri, S.J. Suryaarachi, and H.H.I.N. Gunaratna. And finally, we have the paper titled Low-Cost Implementation of an Autonomous Navigation Robot with LiDAR for Educational Robotics using Raspberry Pi, authored by Gatsara J.A.S. and Sulochana Suryaarachi. Thank you, sir. Next, we have the awards for the Undergraduate Research Showcase of the Research Week 2024. We have the awards for the best posters. To present these awards, I invite Professor Gayatri Ranatunga, Chair of the Research Week 2024, and to accompany her, I invite Professor Virajini Karunaratna, a member of the Organizing Committee of the Research Week 2024. The certificates for the first runner-up award goes to the paper or the poster titled Doppler Radar-Based Drone Detection in Dense Urban Environments, authored by Chirantha Jayampath Kurukula Chatuni Vijayagunawardana, Vikum Jayasankar, and Chamidu Suran Liyanage. Next, we have the award for the best poster of the Undergraduate Research Showcase at the UOM Research Week 2024. The best poster goes to the poster titled Competitive Virtual Cycling over Low Latency Networks, authored by N.D. Liyanage, B.G.D.T. Chatumini, W.K.D. Dilan Senuruk, and B.P.M. Bologna. There is also a cash or a gift voucher of 15,000 to accompany that award. Next, we move to the awards of the ERU Symposium 2024. We have awards for the best paper as well as the best poster. First up, to present the awards for the best poster, I invite Dr. Sulochana Suryaarachi, Director of the Engineering Research Unit of the University of Moratuwa. And to accompany her, I also invite Dr. J.R. Gamage, the Symposium Chair for ERU Symposium 2024. The certificates and the gift vouchers of rupees 15,000 as well as a gift for the best poster of the ERU Symposium 2024 is shared by 3 posters. First, the poster titled Comparative Analysis of Autofocus Measures for Blood Film Microscopy, authored by Hevavitarana DC, Jayatilaka WADM, Dasanayaka VPC, and Amarasinghe YWR. The second poster that is jointly awarded the best poster of the ERU Symposium 2023 is the poster titled Development and Mechanical Characterization of Particle Boards from Water Hyacinth, a Sustainable Approach to Invasive Species Utilization, authored by GGSBK Dharmaratna, WDC Veerasinghe, DGWT Jayalath, and JDC Priyamantha. The third poster that is awarded the best poster of ERU Symposium 2023 is the poster titled Wi-Fi CSI based region detection for adaptive video compression and localization, authored by Yasindan Radhakrishnan, Jasmine Karki, Manoj Kumar Lenka, and Ayon Chakraborty. Next, we have the most anticipated award of today. To present the award for the best paper of the ERU Symposium 2024, I invite Professor Ruwan Gopura, Dean of the Faculty of Graduate Studies, University of Moratuwa, and to accompany him, I invite Dr. J.R. Gamage, the Symposium Chair for ERU Symposium 2024. The certificates and the gift voucher of rupees 15,000 plus a gift is awarded to a comparative analysis of autofocus measures for blood film microscopy, authored by Hevavitarana DC, Jayatilaka WADM, Dasanayaka VPC, and Amarasinghe WR. Thank you, sirs. A big congratulations to all our award winners. I think they deserve another round of applause. Now, to deliver the vote of thanks, I invite Dr. Sulochana Suryarachi, the Director of the ERU of the University of Moratuwa.
Good afternoon, and once again I would like to congratulate all of you for being part of ERU Symposium. And I'll straight start my word of thanks. My first mention should be the Research Week organizers, because this initiative of organizing the Research Week is a large-scale work, and I know the pain of organizing something that big, incorporating all the faculties in the university. And I would like to thank Professor Gopura for continuing the trend, and all the committee members, including our chair of the Research Week and her team. And next, the chair of the ERU Symposium. ERU Symposium is the representation of engineering faculty in the research week, and therefore it marks an important event. So I would like to thank Dr. J.R. Gamage, the chair of the ERU Symposium, and his team in organizing this, because it was a quite a task, because only a handful of people are doing it, but doing it in a better scale, inviting papers from around the globe actually, finally, although we expected papers to come from our universities. And then doing a review process, I know it was a painful journey to get reviews in a very tight time actually, at the end of a year, when the people are busy with various multiple tasks, pending jobs that they have to finish by the end of the year. And after the review process, it was a tedious task to decide the selected posters, and then setting up the environment. So the team, Ransini, Prabhatia, Amantha, Dr. Gayani, Dr. JR, and all their team did a lot of effort, and Falcon team included. And then during yesterday and today, the evaluators did a wonderful job, and they had to spend hours evaluating and listening to multiple disciplines of research. And I would like to mention our post evaluators, Dr. Logishan from Electrical Department, Professor Sudanti Vijay Vikrama, she is from University of Melbourne, visiting us for a short period. And through Dr. Kutila Gunasekara, we were able to get her to evaluate the computer science related posters. And Dr. Chulantha Jayawardena from the Earth Resources Department, Dr. Lihil Subasinghe. Today also he's serving as a panel member. He's been giving us a contribution yesterday and today. And Dr. Aravinda Abe Gunawardena from the Material Science, Material Engineering Department. And today, thank you very much, Dr. Peshala Jayasekara, Dr. Kasundi Silva, again, Dr. Lihil, for spending your time with us. And most of all, you, the researchers, the authors, you have shared your valuable findings, the research effort with us, and believing in ERU Symposium as a worthy place to publish your work. And you're coming from, some of you are coming from long distances. We know the effort you have to put on to travel all the way to University of Moratuwa to present your valuable research and make our research symposium a success. So thank you very much, and congratulations to all of you for being part of the symposium again. And our sponsors and the technical team of the Town and Country Planning Department. Your support was invaluable. Thank you very much. And sorry if I missed anyone. Thank you again for this wonderful effort.
And thank you all for your enthusiasm and support. Your presence and participation at ERU Symposium 2024 have made this symposium a remarkable success. As we mark the conclusion of ERU Symposium 2024, we hope you make this a platform to take your research to even greater heights. And finally, I invite all the researchers and everybody present here for a group photo at the front so that we can officially close the symposium. Thank you.